This lesson is on right triangle trig, right triangle trigonometry. One of the things that I want you to learn is that if the question asks you for an exact value, when they say they want your answer in an exact value, that means don't give them a decimal, because decimals are usually rounded off and aren't perfect. And what they're really asking you for is to leave your answer as a fraction or a root, like a square root or a cube root or something like that, or pi if pi is in the answer, or e if e is in the answer, but they don't want decimals, so avoid that if they say exact value. Something else that we're going to be using that's going to come up and help us get some sides sometimes is the Pythagorean theorem, and the Pythagorean theorem applies to right triangles, so it has to have a 90-degree angle, and you've probably learned it as a squared plus b squared equals c squared. The one thing that I would like for you to remember is that this c is your hypotenuse. So you need to make sure that's the longest side in your triangle. It's the one across from the 90 degrees when you're using the Pythagorean theorem. Okay, so here I have a right triangle that I have labeled ABC, and I have a setup for our 6 trig functions. For those of you who are just used to sine, cosine, and tangent, there are also cosecant, secant, and cotangent. Something else that I want to point out before we get into this is that a lot of times from now on you're going to see triangles and formulas that refer to the sides across from these angles A, B, and C using the lowercase version of that letter. So since this is angle A and it's capital A here, if I go straight across to the other side, this little side would be considered lowercase a. Across from the B, if you draw straight across to the opposite side, again, this side would be considered lowercase b. And then C is our 90-degree angle, so across from it, our hypotenuse would be considered lowercase c. Okay, so, and that's a way you can tell the sides from the angles. The angles will be uppercase letters and the sides will be lowercase letters. Now, you have to remember sine, cosine, and tangent somehow. You may have learned oh heck, another hour of algebra, or some old horse caught another horse taking oats away, or SOHCAHTOA, but you have to know opposite, hypotenuse, and adjacent. Since I'm going from side A, well, first of all, the hypotenuse is always across from the 90, so C is your hypotenuse, and that doesn't change, but the other two, the opposite and the adjacent, change depending on what angle you're looking at. And so we're going to do these from the perspective of A. That makes little a the opposite side because you can draw straight opposite to it, across to it. And that would make B adjacent because it would be next to that A. It actually makes up part of the side of A. And you have to remember, again, that sine is opposite over hypotenuse. So in our case, the opposite being A, the hypotenuse being C, we would make the fraction A over C. That would give us the sine. Cosine is adjacent over hypotenuse. And so in this case, that would be B over C. And then tangent is opposite over adjacent, so A over B. Now, these other three, again, a lot of times we just use sine, cosine, and tangent to figure things out, but in this class we'll be using all 6. So cosecant I have paired with sine because it is actually the flip of sine. Sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, and so it would be C over A. And if you know the sine, you can just flip it and get the cosecant. You'll have to go back and look at the triangle. Secant is the same relationship with cosine, so it's the flip of that. You have adjacent over hypotenuse for cosine, so secant is hypotenuse over adjacent. And so I can flip that, get C over B. And then cotangent has that relationship with tangent, which would be adjacent over opposite, and therefore B over A. Now, notice one of the mistakes that people make is they want to pair sine and secant as being flips, but they're not. They also want to pair cosine and cosecant because the cos doesn't work that way. The tangent and the cotangent people usually get. Just think of it like this way. There's always an S paired with a C. So sine paired with cosine, S and C. Cosine and secant, S and C. Okay, so different letters for those. Now we're going to get into some examples. We're going to use the Pythagorean theorem to find the missing sides and then get the 6 trig functions for angle theta. So again, it's a right triangle, and so I'm missing the hypotenuse. It's the side across from the right angle, and I'm just going to come down here and do a quick Pythagorean theorem. My other two sides, my A and my B, are 3 and 4. So 3 squared plus 4 squared will equal my C squared. That's 9 and 16. So that'll be 25, and the square root of that will be 5. And some of you may know that as a 3, 4, 5 triangle and may not have had to do the Pythagorean theorem. You may just have that memorized, and that's okay too. Alright, now we want the 6 trig functions, so I always like to write them down and set it up for myself. And I would suggest taking the time to do that as well, because it just makes things go faster once you figure out the fractions, because all you have to do is flip them for these other 3. And if you think you can do this, why don't you pause and try it. The sine of theta, since we're doing it from the perspective of theta this time, we can see that this is our angle. So let's label our sides. Hypotenuse is across, again, from the 90-degree angle. It's the one we found. That doesn't change. Since we're from the perspective of theta, the opposite side is across from that, and the adjacent side is what's left. So now when I go to do my sine, I'm looking for opposite over hypotenuse. So this time I have 4, my screen jumped, pardon me, 4 over 5. That would make my cosecant 5 over 4. Cosine would be adjacent over hypotenuse, so 3 over 5. And if I flip that, I get 5 over 3. Tangent is opposite over adjacent, so 4 over 3. And cotangent would be 3 over 4. It's that easy. Okay, example 2 says determine the exact value of the other 5 trig functions if secant of theta is 3. So I'm going to go ahead and write and set those up. I'm going to need sine, cosine, tangent, cosecant, we already have secant, and cotangent. And so without any other work, I can figure out the cosine because it's the flip of secant. So some of you are like, well, how do you flip 3? You remember that it's over an imaginary 1. And so if I flip that, my cosine is 1/3. So I can get that one even if I can't get any of the other ones. But getting that one is actually kind of helpful because that allows me to draw a triangle, and you can pick an angle to be theta. I'm going to pick this one down here. And think about how would it look if your cosine is 1/3. That would mean your adjacent is 1 and your hypotenuse is 3. Okay, that means that we now need to figure out this other side, so it's kind of similar to what we did in the last problem. I have the hypotenuse though this time. I'm missing one of the sides, so I'm going to have 1 squared plus, I'm going to call that b for the minute, b squared equals 3 squared. So 1 squared is 1, and 3 squared is 9, and then if I subtract 1, I get b squared to be 8. And I'm going to go ahead and practice when I take that square root, doing the exact value. So I have the square root of 8, which can be written as the square root of 4 and the square root of 2, which the square root of 4 is 2. So I have 2 square roots of 2. And that means this side up here that I was missing is 2 square roots of 2. So now I can get the other trig functions that I couldn't before. First, with my sine, I have opposite over hypotenuse, so that would be 2 square roots of 2 over 3. And then with my tangent, I have opposite over adjacent, 2 square roots of 2 over 1. And we normally would just write that 2 square roots of 2. Now, for the cosecant, when you flip this, you have 3 over 2 square roots of 2. But we have to rationalize that. So I'm going to come down here and do some more scratch work and rationalize that. So I'm going to get 3 square roots of 2 over, this 2 comes over, the square root of 2 times the square root of 2 is the square root of 4. So I have 3 square roots of 2 over 2 times 2, which is 3 square roots of 2 over 4. And that's how I want to write my answer for the cosecant. The cotangent is going to end up in a similar way, so I'm going to erase and get myself some room. And I'm going to take it back to this fraction to flip. So I'm going to have 1 over 2 square roots of 2 for my cotangent. That's what I have, but again, it needs to be rationalized. So I'm going to multiply by the square root of 2 over the square root of 2. When I go straight across, I get the square root of 2. Straight across the bottom, I get 2 square roots of 4, which will be 2 times 2, giving me a positive 4. So the cotangent, I want to use this, and again, cosecant, I want to use this. Okay, number 3 says determine the other 5 trig functions if the cosine is 6/10. So again, I'm going to set up, I already know the cosine, so I need the sine, I need the tangent, I need the cosecant, the secant, and the cotangent. So if I know the cosine is 6/10, the secant has to be 10/6. And, you know, I don't mind. We can reduce this, okay? So this would be 5/3, but, and this would be 3/5. But that leaves us, again, we have to draw a triangle, and I just tend to draw the same kinds of ones to figure everything out. I'm going to put the theta down here. And if its cosine is 6/10, that means the adjacent is 6 and the hypotenuse is 10. But I have to do the Pythagorean theorem again to find the missing side. So I have 6 squared plus b squared equals 10 squared. So I have 36 plus b squared equals 100. Subtract my 36, and I get 64. The square root of that is 8. So this side is 8. You could have also known that was a multiple of your 3, 4, 5, which is a 6, 8, 10. So that makes my sine opposite over hypotenuse to be 8/10, or if you wanted to reduce it, 4/5. And my cosecant, 10/8, or 5/4. Tangent is opposite over adjacent, so I would have 8/6, which would reduce to 4/3. Cotangent would be the flip of that, so 6/8, or 3/4. Now, this is a really weird and interesting question, so I just wanted to pose it to you. It's kind of like what we were just doing, but you may not realize it at first. It says, if the cosine is y, the cosine of theta is y, what is the tangent of theta? So, what do you know? If the cosine is y, they're giving you a variable instead of a number, but it's still, you know, y over 1. So this would mean your adjacent would be y, and your hypotenuse would be 1. So I'm going to draw a triangle like that. Adjacent y, hypotenuse 1. And I can figure out the tangent, but I need this side. So it's, again, real similar to what we just did. I'm going to Pythagorean theorem. I'm going to call that side x for right now, and say x squared plus y squared would equal 1. And I need to get the x by itself because they didn't give me an x. I made that up. So I need this in terms of y. I need to replace that x with something about y and 1. So I'm going to solve for x over here. So that would be 1 minus y squared. And take the square root. So x will be the square root of 1 minus y squared. So now that I've done that work, I'm going to erase this x, and I'm going to put that this is the square root of 1 minus y squared. And so that's how this is all going to work out. Then I can just look at that and say, okay, well, the tangent would have to be the opposite over the adjacent. So that would be the square root of 1 minus y squared over y. And it's really funky looking, but it's the same process as what we did with the numbers. Now we're finally to some problems that might be real familiar to you, and that would be where you have to solve for a missing side or angle. And so here I have this problem. We're going to find the missing sides using trig. Now once I find one, yes, I could use the Pythagorean theorem, but because we're practicing trig today, I'm going to use trig. So I am first going to find y. And y is opposite of my 30 degrees. So I'm definitely going to be using something with opposite. I don't know what r is. I have to use the 78, and the 78 is on the adjacent side. So opposite and adjacent go with tangent. So I'm going to write my statement, tangent, instead of theta this time, I know that it's 30 degrees. Tangent of 30 degrees equals y over 78. That makes my equation. Before you start typing in your calculator, check and make sure you're in degree mode, because in this class we will change different modes, and we want to make sure you're in degree mode to plug this in. Okay, to get the y by itself, you have to multiply both sides by 78. They cancel here, and so what you're wanting to type in your calculator is 78 times the tangent of 30. Or you know your unit circle. If you know it, you could plug in from there. If you don't know it, you will be learning it in this class. So we have 45.03 if you typed it in your calculator and got a decimal. And so that is your y. Now we're going to get the r. I'm not going to use the y just in case I made a mistake. I'm going to go back to the 78 because I know that side for sure. So that's my adjacent side, and since I'm trying to find r, that's my hypotenuse. Adjacent and hypotenuse go with cosine. So I'm going to set up an equation. Cosine of 30 degrees equals adjacent over hypotenuse, so 78 over r. So this fraction is actually upside down from what this one was up here. Still doesn't matter though. The only way to get rid of this fraction is to multiply by the denominator. So in this case, I multiply both sides by r. So I have r times the cosine of 30 equals 78. And then I'm trying to get r by itself. The cosine of 30, you know, is some sort of decimal that if you typed it in. So r times a number, we need to divide by that. So 78 divided by the cosine of 30. And then you want to type this in your calculator. And again, if you've checked the mode, you're in degree mode, you're okay. It's not going to change between problems. You don't have to check it every time once you've done it the first time. So just type in and you should get 90.06. Okay, our last example, example 6, is similar to example 5, except this time we're missing an angle. And so not all the sides are labeled, sometimes they all are. And if they all are, you can pick almost anything, sine, cosine, tangent, whatever, to solve with. But here I have to decide which two I have. And looking at it, I have the hypotenuse and the adjacent. And then you decide what do I use with hypotenuse and adjacent, and that would be cosine. So I'm going to write my statement, cosine of the angle x equals adjacent over hypotenuse. And when you're missing the angle, it's different. You can't just multiply by 42 and then divide by something weird. It doesn't work that way. When you're missing the angle, you have to use the inverse. And if you'll look on your calculator above your cosine button, usually in blue is an inverse. You'll have to hit second to get to it, but that's what we're going to use. So your x is going to be the cosine inverse of 21 divided by 42. And that's how you want to type it in. And if you type it in correctly, you should get 60 degrees. And this is an angle, so you want to make sure you put the degree mark here.